Don't forget to subscribe and ring that bell.
Welcome back for problem number two. Yes, we are here for problem two. I'm excited to do this. You might not be excited, but you can at least act like you're excited because you got to be here. You're here because you either got this assigned to you and you don't know how to do it, or you're studying for the AP Calculus AB exam, which either way is a positive thing. We do get a graphing calculator, so coolio. 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 That's cool. All right, let's start. Oh, 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 we have a graph, kids. Kids, I love graphs and tables and charts. Oh my, I love them. Look it. Let f and g be the functions defined by f of x is 1 plus x plus e raised to the x squared minus 2x. And g of x is x to the fourth minus 6.5x squared plus 6x plus 2. Let R and S be the two regions enclosed by the graphs of f and g shown in the figure, well, to the bottom left. Find, well, this is 2a now, find the sum of the areas of regions R and S. Man, I'm really excited I can't even read. Now, you might be saying to yourself, that's kind of a f of x is a little tough. We're gonna have to integrate these things. You get a calculator. This is when you get calculators, the only thing you should worry about is the setup. Don't worry about doing any of the math because we are going to use the calculator. All right. First thing, we need to determine which graph is f of x and which graph is g of x. Because unless there's two corners, okay, unless there's a corner here, dot, 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 like that, and there's a corner here, bang, which I don't think is the case. I think they intersect right there at that point. I think one graph comes up and down, and the other one comes through. So I'm going to need to know that point of intersection, and for area R, which graph is on top, and for area S, which graph is on top, okay? So why don't we just put these in our handy dandy calculator? Here we go. RAM is cleared. Thank you. And let's take a look at our graph. So y equals. I will put f as the blue line. So it's 1 plus x plus e raised to the x squared minus 2x. All right. And the red line will be g of x. We have x to the fourth. Make sure I pop off that exponent. Minus 6.5x squared plus 6x plus 2. Now, I'm going to be honest with you here. If you notice, okay, if you notice, I am only going to 0 on the x and 2 on the x, which will be right about here. And I'm only going as high as 4 on the y, which would be right here. So this would be 4, this is 0, this is 2. So I'm going to change my window to show just that. Okay, I don't want to see 10 by 10, 10 by negative 10. Garbage. I don't need it. So let's go to window, and I only want to go from 0 to 2 on the x. And let's go to from 0 to, I don't know, 4.25 by ones, or 4.5 by ones. Okay, so f of x is the one that starts down and comes up. And g of x is the fancy dippy one. Okay, g of x, okay, g of x, and let's make absolutely sure. Yep, g of x is the red one. So what I'm going to do here, red, g of x is this one that comes up, down, and back up. This is g of x. And f of x is just this little loopy one. Goes right through here. That's f of x. We've identified what is what. We also need this point of intersection right here because I need that value down below. Because if I'm going to find the area, wow, that's a very disturbing little tick mark. I guess it's somewhat better. We are going to need to know because the higher function changes depending on what region we're in. I'll explain that in a moment. First, let's find the intersection. Oh, hit enter 3 times. And that happens to be at 1.033. Okay, I'm going to round that thousandths place to a 3. So that's at 1.033, my point of intersection. So if I want the area, let's start with R. If I want the area of R, it is the top curve minus the bottom curve. Notice that g of x is on top of R, in the R region, I should say. The integration of g of x minus f of x, don't forget dx. We're starting at 0, and we're going to our intersection point of 1.033. Now, I've got to add that, okay, because we're trying to find the sum of R and S. And right here, this is how I get the area of R. Okay, I've got to add that to the area of S. How do I find the area of S? Well, I integrate from 1.033 to 2, because those are the bounds here. But now f of x is the big function. It's the one on top. So it's 1.033 to 2. Now f of x is on top minus g of x dx. I literally put that in a calculator. It's a bit of typing. I don't care, because the calculator is going to do it all for us. So let's quit out of here. Math 9 is my integration from 0 to 1.033. Here we go. Let's do, and I'm going to put parentheses around each function. So the first one is g of x minus f of x. Okay, g of x is, oh man, x to the 4th minus 6.5x squared plus 6x plus 2, parenthesis, minus f of x, which is 1 plus x plus e raised to the x squared. Oh, come on, where are you? X, there it is, squared, minus 2x. Put that parenthesis there. Dx. I got to do the whole thing again, but just switch f of x and, oh my lord. There you go. Now I got to do the whole thing again, but switch them and change the bounds. Math 9. Now I'm going from 1.033 to 2, but this time f of x is first. 1 plus x plus e raised to the x squared minus 2x. That one wasn't too bad. Minus g of x. Here we go. X to the 4th, pop off there, minus 6.5x squared plus 6x plus 2. Goodness gracious, dummy variable dx. There we go. So I'm going to add those two together. Those are my two integrals. This plus this. 2.004. Oh, goodness. That is approximately 2.004. That was a lot of typing in the calculator. just to get that problem, but who cares? Just make sure you type it in correct. I think 2B is going to be easy, and I think 2C is going to be easy as well, but, let's see. No pun intended. B, region S is the base of a solid whose cross sections are perpendicular to the x-axis and they're squares. Find the volume of a solid. Guys, whenever we need volume, we integrate area. Our area is area of squares. And the area of a squared is side squared. So I'm going to integrate side squared. Now this is just area S. I only care about this area here. Remember, if we did this right, and we did, f of x is on top here, and g of x is in the bottom here. Not only that, it goes from point 2 to point 1.033. Those are my bounds. All right. And finally, squares are going to go from here to here, and it's going to be kind of like a square. Here to here, and we're just going to stack a whole bunch of squares. I know these look like rectangles, but they're kind of standing up. That looks like an hourglass. Oh my God. So I think you get the picture. So I've got to stack a bunch of squares on top of each other. So the question is, let me get rid of those horrible squares. What is the length of the side of this square? From here to here is the side. It pops up. Okay. That length is whatever f of x is minus the value of g of x. Let me say that one more time. It's whatever f of x is minus whatever g of x is. Okay. So my side is f of x minus g of x. So I'm going to integrate my side, f of x minus g of x. But don't forget, I got to square it. The area of a square is side squared. Don't forget your dx. And our bounds are 1.033 to 2. Man, we got a lot of typing in the calculator. All right, let's, maybe I can cheat here. I'm going to be bad. Which function was f of x minus g of x? It was this one. Oh, Lord. Now let me just retype it. I'm not going to be, it even has the same bounds. You know what? Let's see what we can do here. I've got to take this whole function and square it, which means I got to take f of x minus g of x, which starts at this parenthesis. I'm going to insert another parenthesis, and I'm going to close that. There's f of x right there. Here's the start of g of x. And that ends right, come on, here. Which means I'm going to close the parenthesis. I put a parenthesis in front of both of this subtraction problem. I got to close that parenthesis. That's my side. I have to square it. Boop. 1.283. 1.283. I like it. 1.283. It says nothing about label. So there you go. That was pretty simple. 2C states, let h be the vertical distance between the graphs of f and g in region S. Again, we are only focusing on region S. All right, and we know that f is the top graph. That's f. And g is the bottom graph. Right here, g. All right. Find the rate at which h changes with respect to x when x is equal 1.8. First of all, what is h? H is the difference. It's the vertical distance between F and G. Remember, anytime I'm doing this stuff, it's F of G, F minus G, right? This vertical distance, all right, let's do this. Right here, I want the distance from F to G. So what I'm going to do is I'm going to take F, which is the distance from the x-axis there, and I'm going to subtract the distance of G. So if I take this out, that's what I get. So really, it's F minus G. If they want me to find the rate at which H changes, I really just need H prime. Okay, which means I got to take F minus G, okay, and take the derivative of that. And I want that at an x value of 1.8. I mean, you know, if you're one of those people who's like, you know, Visca, you should put the x's there, taking the derivative with respect to x of f of x minus g of x. You know what? Good for you. At x equals 1.8. Again, we're putting this right into the calculator and hitting enter. That's all we're doing. Okay, so let's go here, let's go here, let's go here, let's go here. I wonder, can I delete the integral and keep the integrand? No, I'm probably going to, no, don't tempt me. All right, so I'm going to go to math 8. That means I'm going to take the derivative with respect to x. In here, it's going to be f of x minus g of x. So it is going to be in parentheses 1 plus x plus e raised to the x squared minus 2x minus g of x, which is x to the fourth, minus 6.5x squared plus 6x plus 2, close that parentheses. Where do I want it? When x is 1.8. Booyaka, booyaka, right there. Negative 3.812. Negative 3.812. Was it 812 or yeah, 812. It says nothing of a label, and we we done. All right. I'll see you for problem number 3. Bye-bye.
Don't forget to subscribe and ring that bell.